Hi, good evening. I hope you can hear me and see me properly. Anyone has any problem regarding the video and audio? Let me know. Here, the thing is, you can't unmute and you can't talk. If you want to send me this message, then it is only through the chat. It is done to make our then class quite comfortable. If I ask you to unmute and then answer, in that particular case, sometime I have that experience. Sometime all of us hear all the other noises also. Sometime your mother and father is having they are having some kind of argument, then we all hear that one. It's not good, any. Sometime your mother is scolding you. Then we can hear that one. Not only me, then all of us can hear. That's really a disturbance. So that is why I didn't give you the permission to unmute. That make our class quite comfortable, peaceful, and calm. So we can continue without any difficulties. Ne? I hope you have that experience. I mean, sending the message through chat and everything. I think your typing speed will be quite pretty good. Therefore, no issue regarding that one. Any doubt you have, just communicate through the chat. Next thing, you know the purpose of doing this class. This is related to our physical classes doing at Farade, Kandy, and Farade Vattal, both classes. Right? The purpose of doing this class is not to discuss the theories. So once you consider, then first 4 notes, I think, up to de Broglie Wavelength, we have covered it. Now we covered, we are going to start note 6 also completed. I can't remember. Then this covers only the note 4. I mean, the questions from these sections, note 4 up to de Broglie Wavelength. Then we discussed actually once we discussed the theories, the theory was immediately followed with question. You remember that one? That's my way. Even within the class, we discuss large number of questions to develop the confidence. But other than that, I have given some questions to develop confidence. Thereafter, I have given past paper questions to test your confidence. 20 questions to develop your confidence regarding this section. Thereafter, I have given more than 20 past paper questions. I mean, those past paper questions since 2003 to 2024 means more than 20 years past paper questions based on the section we discussed so far. So those past paper questions given to test your confidence. First to develop your confidence and then test your confidence. Therefore, this class is to discuss these questions. Sorry, I can just give the homework sheet only and then move to the next thing, and then I can give you another homework sheet like that. But I think just giving homework sheet not enough. Discussing all the questions will be really helpful, because when I explain the theory, you learn it. But some people then can understand the theory properly through the question discussions only. Therefore, it is really, really important to have this discussion. Got it? So for the next homework sheets also, I try to maintain this type of, I try to keep this type of online session as the discussion, because I can discuss this one in our physical class at Farade, but it takes some time. You will see sometime. I plan today only 2 hours class. We will see whether we can finish this within 2 hours class. But sometime you ask doubts, then when I explain those and stuff, then sometime we need more time. In that case, then I will arrange another online session next week to cover this homework sheet too. So then, because I have planned to give you the homework sheet 2 This is first one, homework sheet 2, the next coming weeks, not next Sunday and Tuesday. The following Sunday and Tuesday, I will give homework sheet 2. That will cover the notes from 6, 7, maybe 4, then 5, 6. 5, 6 will be covered. Got it? Hari. Then you understood the purpose of this class and everything. I hope then you participate this class after completing those questions. It is really important. If you haven't even seen that questions and you participate this class, I think it's not then quite successful. The best thing is to complete those questions, find some difficulties, mistakes. Then only you participate and understand your mistakes, understand how to approach the question easily, understand the techniques, short methods, tips and tricks through the discussion. That's why I'm doing this one. Okay, shall we move to it? I hope all of you have the tute to it in the homework sheet. I shared that one. The class student got that tute homework sheet about 1 week or maybe 2 weeks ago. Maybe here there are some people who are outside the class, but yesterday I shared it, ne? I think yesterday. So this is the homework sheet 1. Let's go to these questions one by one. But some questions I will not discuss in detail. As example, the first one. I'm not share this one because I hope all of you have it. So what's the first question? First question is about the cathode ray experiment. Actually, this comes under properties of cathode rays. Ne? Then you are asked to label the diagram. You all know how to label it. We have cathode rays, paddle wheel, anode. These are in the note. Therefore, I don't explain that in detail. What are the observation of this experiment? You remember that observation, ne? That paddle wheel rotates and moves from cathode to anodes. That's what happened. What are the conclusions? The conclusion is what? Conclusion should be like this. Maybe you already answered it, then check your answers. Within the conclusion, there must be these points. I mean, cathode rays have mechanical effect. That must be there. Cathode rays have mechanical effect. Or in other words, you can say cathode rays can do work. That's one conclusion you can have. Second conclusion, because it has mechanical effect, because it can produce work, then there should be a particle nature. Cathode rays has particle nature. That's why it can produce some kind of work there. Work is force into displacement, force is mass into acceleration. You know, mass particle nature is there. That's another thing you need to do. Another thing, then I said this paddle wheel rotates from, the moves from cathode to anode. From that, you can have conclusion regarding the direction of cathode rays. So what's the direction of cathode rays? It's from the cathode towards anode. These 3 points should be there. Got it? Can produce work or has mechanical effect. Second, particle nature. In other words, cathode ray consists of particles. Next thing, the direction of cathode rays should be from cathode to anode. Those are the conclusion you can have from this. That is enough for the first question 1. Question 2, charged particle is caused to move between two electrically charged plates. I hope you have the tute. Why does the path of the cathode particle bend, a charged particle bend? You know why it is bent? Because it's a charged particle and the metal plates are also charged. Then there can be attractive forces and there can be repulsive forces. Definitely, the path of this charged particle should change. Right? So, especially there must be like this. It's a charged particle. Plates are charged. Then there can be attractive forces and repulsive forces. That's enough. So, that is why it then changes its path. Got it? What is the sign of the electrical charge on the particle? You know that deviates from, towards positive plate. Ne? All of you have it, ne? So this is your diagram. This one is our diagram. You see, then the ray goes, the particle move or deflected towards the positive charge plate. If it is deflected towards the positive plate, you know there is attraction between the positive plate and particle. There is repulsion between the negative plate and particle. Then from that you can easily conclude attraction between positive plate and particle mean definitely particle is negative. Repulsion between the negative plate and particle mean particle is negative. That's how we decide the charges. As the charge on the plate is increased, would you expect the bending to increase, decrease, or stay the same? Then this one is quite important because during radioactivity theory part, I explained this part. I hope you remember. In the case of C part, I talk about a certain point. You remember that? What's it? Deflection angle. Deflection angle. Deflection angle is directly proportional to the charge to mass ratio. That's what I said. Maybe you remember we discussed that theory. Deflection angle is directly proportional to charge to mass ratio. In other words, I can say deflection angle directly proportional to the charge and deflection angle inversely proportional to the mass. I don't explain the theory. I told you the purpose here of doing this class is but just to show you how to answer and what are the points that should be included to your answer and how to what I expected. That's another important thing. Sometimes you answer this question and you write everything you know, but it is not the proper way to answer exam questions. You should know what they expect from this question. It comes by the experience. Now at the beginning you don't know that one because you can't read the other's mind, but through the experience you can easily understand what they expect. Then these are the points I should write. Likewise, it comes by the experience. Don't worry now. Then deflection angle directly proportional to charge to mass ratio or directly proportional to charge, inversely proportional to mass. Now the question is this: as the charge on the plate is increased, charge of the plate is increased mean E increases. E refers actually the charge of particle or even the charge of the plate, doesn't matter. E refers here the charge of particle or charge of plate. Then whatever it charge increases, definitely the deflection angle should increase. Then it should increase. Thereafter, as the mass of the particle increase, while the speed of particle remains the same, speeds remains same. It doesn't matter. So mass increases. What happened when mass increases? Since it's inversely proportional to this, definitely the deflection angle should decrease. That's the way we answer. Just decrease enough. To explain it further, you can just put it like this: deflection angle is inversely proportional to the mass of the particle. That way you can answer it. Since these questions, then what's the answer for 2B? 2B, where is it? 2B. 2B, what is the sign of the electrical charge on the particle? Since the deflection is towards positive plate, there should be attraction between positive plate and the particle. Then where do you find attraction? Same charges or opposite charges? Opposite charges. If plus attracts the particle in ray means definitely it's negative particle. So the 2B, the answer should be negatively charged. What is the sign? It's negative. So during this discussion, some questions I discuss quite fast because I hope this is enough. I mean, this explanation is enough. But still you have some doubts regarding that. Definitely you need to send your doubt through the chat. Then I can explain it. All the messages I will read and then respond to them. Then you ask marking scheme. The thing is this one, then I will keep this one and anytime you can refer this one, and I think better you write the review in your words since you are now free these days. I mean, you are not busy, you just started A level. in that case, I can give complete answers and everything in the hard copy or PDF even. But the thing is, I think it's not the way. You have to do something. The activity is this one. You can go through this recording and everything again and write your review. In your word, you can just complete the answer. Got it? You need to, I know at the beginning it's not quite comfortable, but later you will see it's really effective. So what is the answer for the second C part? Second C part, they ask, as the charge on the plate is increased, would you expect the bending to increase or decrease? Then the bending means this one. This is the initial path. Then it goes like this. Bending means this one. We are talking about the deflection angle, theta. So this deflection angle, I told you, directly proportional to charge to mass ratio. Or in other words, you can say direct deflection angle is directly proportional to the charge of the particle or the plate, inversely proportional to the mass. So if you ask to C, they ask as the charge on the plate is increased. So which one they increase? Charge of the plate, E. Since theta directly proportional to E, when you increase E, theta should increase. Theta increases mean deflection angle increase. Deflection angle increase mean the bend increase. So it should be, they ask bend increase, decrease, same. Your answer should be increase. Yes, that's all. D, they ask then as the mass of the particle increase while the speed of the particle remains the same, what would you expect? Increase, decrease, or same? Then if the mass increases, since theta inversely proportional to mass, when you increase mass, theta decrease. Theta decrease mean deflection angle decrease. Deflection angle decrease mean the bend decrease. Now it goes below this one. Bend decrease. So it should be decrease. Give the direct answers. No need to then write in detail. If they ask explain, then you have to explain. Otherwise, just direct answers. Got it? When we move to the next question, can you see that one? I mean, it is, straightforward question. What is the mass of an electron? It is there in the note. Find it and write it. I can't do everything. I know what to expect, then everything from me. No. You have to do your own then study part. Self-study part is essential in the case of failure. This is a kind of side help I am giving. What is the mass of an electron? 9.108 10 to the power of minus 28 gram. It's there in the note. What is the charge of an electron and who found that? Again, you know the charge, minus 1.6021 10 to the power of minus 19 coulomb. Who found that charge? Millikan, Millikan. It's directly, you can find that one in the note. What is the charge to mass ratio and who determined it? Charge to mass ratio 1.759 10 to the power of 8 coulombs per gram. Who found that? J.J. Thomson. J.J. Thomson. Does the gas inside the cathode ray tube affect the EM ratio? That's again under properties of cathode rays I explained. You know charge to mass ratio, simply then, the nature of the cathode ray. What did they ask? Does the inside cathode ray tube affect the gas inside the EM ratio? No. I explained that one because charge to mass ratio, charge is for electron. This is charge of one electron. Mass is also for electron. It's the mass of one electron. Then wherever you find electron, the charge is same, the mass is same. As example, if you have an electron from hydrogen, there is a certain mass. Electron from helium gas, there is certain mass. What about the mass of electron of hydrogen and mass of electron of helium? Same or different? Exactly same. What about the charge of electron of hydrogen and charge of electron of neon? Exactly same. Then if the charges are same, if the masses are same, charge to mass ratio also same. Got it? Therefore, charge to mass ratio, E over M ratio for cathode rays does not depend on the type of gas. It doesn't depend on even the type of material you use in anode and cathode. Got it? So it is then, does the gas inside cathode ray tube affect? No. Does the electron have both wave and particle nature? What is your answer? Yes or no? Type it. Question number 3, part E. Does electron have both wave and particle nature? What do you think? Type it. Yes or no? So EM ratio comes as a negative value, right? Yes, yes. For electron, charge to mass ratio negative. For electron, because negative divided by positive, negative. Yes. For electron, it's negative, but if you think about EM ratio of proton, it's positive. It depends on the particle you have. What is the reason for that? I miss that one. What is the reason for that means? What did you... I don't see your name, only 2 dots. What is the reason for that mean? What did you ask about that? So I'm new student in theory class. Which lesson do you teach? Atomic structure lesson over. Atomic structure lesson is not over. I told you then we are doing atomic structure quite slowly, because atomic structure and bonding, these 2 units are the basic and the foundation fundamentals for the other complex units like inorganic chemistry, organic chemistry. To understand those concepts, you need each and every concept you learn in atomic structure and bonding. Therefore, you need to understand that 100%. Therefore, I just maintain quite small, the low speed. That's why still it is not over. Okay, it's not over. Atomic structure, these days we are doing now hydrogen emission spectrum finished. Then we are talking about quantum numbers. After quantum numbers, it will be electron configuration. After electron configuration, it will be periodic table, the last part. Hari, I can see your answers. Most of you say yes. Yes. Yes means yes. Yes, it's correct. What did I ask? Does electron have charged particle nature and the wave nature? Yes. Under suitable conditions, electron can behave as a particle. Electron can behave as a wave also. Then it can produce mechanical effect in cathode ray experiment. You remember that one. Can produce mechanical effect mean it has a particle nature. The other thing, it can cast a shadow. Someone can cast a shadow mean, remember, it is a wave property, like sunlight. That's one thing. The other thing is, the Louis de Broglie, that man explained that particle nature, wave nature, everything regarding the electron. He said the electron moving around the nucleus moves not in a circular path. It moves as a wave. That's what he explained. Therefore, he defined equation to calculate the wavelength of electron also. Lambda equals h over p. You remember that one? Therefore, yes, electron has particle nature, mv, momentum, and electron has wave nature, lambda. Yes, you are correct. It should be yes. Good, you know these things. Sorry. Question number 4. They ask, do the proton and the neutron have exactly the same mass? No. You can find the masses numbers in the note. It's 1.6729. 10 to the power of minus 24 gram is the mass of proton. 1.6746 or something, yes. Into 10 to the power of minus 24 gram is the mass of neutron. It's approximately same, but not exactly same. They ask, do the proton exactly same? No. How do the masses of the proton and neutron compare to the mass of electron? You have to say then mass of electron is very small, or mass of the proton neutrons are very large. Even you can put the number also. What's that number? 1800 40 times the mass of electron. Mass of proton is 1840 times the mass of electron. And mass of proton, mass of neutrons are approximately equal. Right? You have to say proton, neutrons are very heavy particle compared to electron. And to explain it further, you can give that number also, 1840. That's enough. Which particles make the greatest contribution to the mass of atom? It's very clear. Particles that are found inside the nucleus. Means protons and neutrons. Direct answer, protons and neutrons. Which particle make the greatest contribution to the chemical properties of an atom? Still, you have not discussed the reactions and all stuff. The chemical properties part, that will be discussed mainly in inorganic chemistries. Inorganic chemistry. You will see that you already know that one. I mean, proton, neutrons are inside the nucleus. That is at the core of the atom. They can't then participate or they can't interact with the outside. But outside the nucleus, you can see, you can find what the electrons. These electrons are, I mean, these are not covered by anything. It's outside the nucleus. These particles can interact with the outside very easily. Sometimes they can lose that electron. Sometimes they can add more electrons. Of course, it is electrons. It is electron. Which particle make the greatest contribution? So it should be the electron. Those are the answers should be for question number 4. Yeah, you remember that number. Eh? Question number 5, they ask this one. Explain briefly why these two are regarded as isotope of uranium. You know the definition for isotopes. What's it? Same atomic number, different mass number. These two have same atomic number, 92, 92. These two have different mass numbers, 235, 238. Same atomic number, different mass number. That's all. Then the percentage abundance is given. You are asked to calculate the average atomic mass. You know how to do that one. Everything we did large number of questions. I mean, regarding this one within the class. One is 235 isotope, and the percentage abundance is just 0.72%. Other 238, the percentage 99.28%. How to get it? I asked you to calculate the average atomic mass in this manner. Take the isotopic mass, 235. Multiply that one with the percentage abundance. It's 0.72 over 100. What about this one? Take the isotopic mass, 238. Multiply that one by the percentage abundance, 99.28%. Then I ask you to add them. Sum of the product of isotopic mass and the percentage abundance will be the average atomic mass. Thereafter, you can simplify this and get the final answer. 100 is common. Simplification part, then it's not chemistry. But it is, simplification is there in chemistry. That is the problem some of you are having. 235 should be multiplied by 0.72. Here to save the time, I use the calculator. 169.2. I am giving the value, final value, because then you can check whether your answers are correct or wrong. But maybe already you check it with the calculators. But my advice, do not use calculators once you do these type of questions in home. In the class, I don't give you any chance to use it. Is this 23,000 something? Yes, 23,628.64. Then you will add something to this. What's it? 169.2. Then you will divide that by 100. You get 237.9784. This is the exact value. 237.9784. That's the average atomic mass of uranium according to the given information. Yes, good. 237.97, yeah. 277.9784. Yeah. Up to if you take this up to 2 decimal place, you know what to do. You can't leave it like 97 because the next number 8, it should be 98. If you leave it like up to 2 decimal places, you can't leave it like 97. It's not correct. Next one is 8. Better you see that one also. As the number of protons differ for every atom, it can be also considered. Can be also considered. Yes, for what? You mean the regarded as isotope? Sometime I check quite late. Fourth question, D part. That's the way. Fourth question, D part. Which particle make the greatest contribution to the chemical properties of an atom? As the number of proton differ for every atom, it can be also considered. Yeah. Yes. Because according to the atomic number, we write the electron configuration. According to the electron configuration, we can predict the chemical properties, but mainly, again, electrons. It must be electron. Even number of proton changes, then atomic number changes, then the electron configuration changes. That's why the chemical properties changes. In that case, again, electron configuration mean again electron. So out of the subatomic particles, which one then most contribute to chemical properties? Yeah, there is a clear answer. Electron, which must be electron. Aren't we allowed to take round off values to, I took 0.72 as 1%? No. In these type of calculations, you can't round off this to 1 and then do simplification because it makes it easy. No, you can't change the questions given in the paper. If the number given 0.72, use that one. Don't take it like 1 and exactly the answer will be wrong, because in the marking scheme, they will give small range. Like if this answer is 237.97, they will check 97 will be accepted, 98 will be accepted, 96 will be accepted, but that's all. So if you take 1 here, there will be large deviation. It's not good. Got it? Correct. Sixth question, chlorine has 2 isotopes, 35, 37. Percentage abundances of 35, 75. Calculate the relative. Then this is also similar to the previous one. 35. Then if you're asked to calculate average atomic mass, take the isotopic mass multiplied by 75%. Abundance, yes, 75%. The other one given 37 isotopic mass. And if this is 75, other one is not given. I think you can predict it. All of you know, sum of percentage abundances of all the isotopes is equal to 100. So if this is 75, next one should be 100 minus 75. What's this? 25. We add them, we get the final answer, 100. That's the common part. Then 35 into 75, we get like 2625 plus 37 into 25. Yeah, 925. 5510 1, 22415, 6915 1, and it's 3 divided by 100. So we get 35.5. We have a nice answer for that one. 35.5 will be the answer for question number 6. Good. Yes. So, what about discussion of these questions this way? Sometime the past paper questions, I will discuss them in detail. Sometime I take long time to explain. But for these type of simple question, I discuss in this manner. I think you are okay with that one. Do you have any suggestions? Then let me know. I'll consider them. Question number 7, sometime not familiar to you. But in our theory classes, I briefly explain this mass spectrometer part. Neon 20, neon 22 identifies as two isotopes of neon. According to the mass spectrometer analysis, the percentage abundance of first isotope are 9 times greater. Here there is something to discuss. Neon 20, neon 22. It's given the percentage abundance of this first isotope is 9 times greater than that of second. Hurry. If the percentage abundance of second one X, what is this? It's 9 times, means 9x. Ne? Those are the percentage abundance. But quickly we can find it out because addition of percentage abundance is equal to 100. There are 9x plus x should be 100. 10x equals 100. So what is x? X is 10. So if this is 10, this is 90%. Quickly we can find it in this manner. Then they asked to draw the graph for the results of mass spectrometer experiment. Right. Very okay. They asked to just to draw the mass spectrometer. So what do we have in mass spectrometer? This is where we get simply intensity. Intensity means how many hits you get on the detector at a certain point of the detector per second, maybe per second. That's the intensity. So you get more and more particles, 9 to 20 particles, then there will be more intensity. If you get a small number of 22 particles, so isotopes, then you get small intensity. That's the secret. But in this particular case, actually not exactly mass. It's given mass over atomic mass and divided by the atomic number. That's how we get it. Then this can be like 20 divided by 10. This can be 22 divided by 10. Mass over Z. Then at 20, it's 90 times, then let's start with this one. Then if it is like 1, 2, 3, 4, 5, 6, 7, 8, 9, like that, then this is 10. This should be 9 times. The peak should go up to 9 and then come down, and there will be peak here up to 1. That's the point. So this is 9 times or 90%. This is 10%. 10, 20, 30, 40, 50, 60, 70, 80, 90. Got it? If you have drawn this graph in this manner, that's enough. Clearly, this height should be 9 times this one. Masses will be 20, 22. If you have given it like that, then it is complete answer. Calculate the average or relative atomic mass of natural atom. So in that case, we can use this information and calculate as I explained. Average atomic mass of neon will be 20 times 90% plus 22, 10 times this one. Then actually this is cancelled. Right? We can take 10. This is 0, 180 plus. This is 22. So what do we get? It's 2. 22 and is that 2? Okay, then this is 2. 10 and 2. Divided by 10. So 20.2. 20.2 is the average atomic mass of this element, neon. Good. That's about 7th. 8th one also quite similar. The element A has 3032. Average relative atomic mass is given. Calculate the percentage abundances. Again, quite similar, and all of you can answer it. A, what are the numbers? 3032. Very similar to this one. Earlier 2022, now 3032. And the percentage abundances are the question. Calculate the percentage abundances. Sorry. Then you know what to do. We don't know percentage abundance. Some of you can get A or something, or X, doesn't matter, whatever you like, the symbol. Then you can put the other one Y. X, Y. But what about that situation? I asked you not to get the different, the more and more unknown factors, unknown parameters. Because if you get large number of unknown parameters, then it will be quite difficult for you to simplify it. Okay, you need more equations to simplify them. Better you put it like X and express the other in terms of X, then only have one unknown parameter. It can be done because you know the addition of these two, but addition is 100. Ne? So if this is X, this must be 100 minus X. Ne? That's simple. Then we write the equation for average atomic mass. So it will be like 30x%. This is 32. 100 minus x%. Then you add them. Do you know this value? Yes, it is given. What's that value? It's given 30.2. It's a nice value. 30.2 equals, this is 100. What about this? 30x plus 3200 minus 32x. Do the cross multiplication. It's 3020 equals 30x minus 32x. It's 3200 minus 2x. We are not comfortable with minus, then we take it here plus 2x and we take this value to the other side. 3200 minus 320. So what do we get? 2x equals like 0. This is 8. 0 minus 0. Okay, then 10 to 8. And what about this? 1 remains, 180. So what about x then? It's 90. X 90. That means this isotope, the percentage abundance 90. The other is 100 minus x means 10%. So 90%, 10%. Yeah, correct. So that's what I expect, right? I mean, you should have done this part. With your answer, you need to participate this discussion. That's the best thing. Up to this point, then the questions are not difficult, easy. But once we go to 9th question, there is something we need to understand, but still it's manageable. I know your IQ level is quite high. That's why you selected science subjects in A-level. So those who have good IQ level, logical thinking, simplification, maths skill part, everything high, then they don't find any difficulty here. Look at the 9th one. The 3 isotopes of Q, 16, 17, 18. Q has 3. I'm talking about 9th question. 16, 17, and 16, 17, and 18. Average atomic mass is given. Yes, relative atomic mass of this element 16.2. Percentage abundance of 7 is twice that of 18. 17 is twice that of 18. Then look at this. Better we start with 18 then. It's x. Percentage abundance of 18, x. But if the percentage abundance of 18x, then what could be 17? 2 times 2x. What could be 16? Do you take it like y or something? No need to take it like y. I told you, don't take more and more unknown parameters because we can express that in terms of x. Do you know what to do then? Let's say you took it like y or something. What's the addition of this? I mean, y plus 2x plus x, what's that? It's 100. I told you then percentage abundance, that addition should be then 100. So therefore it should be y equals 100 minus 3x. Then don't take it like y, take it like 100 minus 3x. This is 2x, this is x. Those are the percentage abundances. You get only one unknown parameter. Quickly you can find the answer for this. They ask determine the percentage abundance of 3 isotopes. Yes. Average atomic mass is given. Let's write the equation for that. It's the 1600 minus 3x percent. This is 17 2x percent plus this is 18x percent. Ready? 100 common, then you can simplify 1600 minus 48x plus 34x plus 18x. What about this value? Is it a good one? 16.2. Yes, good one. Multiply that by 100. It's this. What about this? It's okay, 1600. What about this? I mean, plus 34 plus 18. What do we get? It's then 52 plus 52. Plus 52 minus 48. What do we get? Minus 4x. Plus 52 minus 48. Plus 4x, not minus. We get plus 4x. Plus 52 minus 48, plus 4x. Keep 4x that side and take this to the other side, 1660, 1620. Minus this one, so we get 20. Then 4x, 20. Then what about x? 20 divided by x is 5. Can you see that one? Is it too low? You can't see that. Can you see that the x5? You can see it. X is 5. Yeah, this one is 5. 2x, 10. 10 plus 5, 15. Then it should be 85. That's how we get the percentage abundance. It's a kind of good question. The way the data given is quite tricky, but still you can manage it. 32, 10%, 32, 10%. The previous one. 18, 5. Yes, correct. Yeah, correct. Correct. This type of question then can be managed in this manner. But next question is, I mean, nothing to discuss, same story, but only difference is, I'm talking about the 10th question. The difference is the numbers, 2 numbers given. But within the class, I told you, when you are given 2 numbers, I mean, the nice value is there 340, the isotopic mass, but there is a very bad value within the bracket 339.89. So what do we use? I know you like to use 340, but unfortunately, in this time, you have to use the bad value. I mean, 339.89 exact value given, then that should be used. Sometime that's the way, even in the life. If 2 options available, we really like for option 1 because it is convenient, easy. But the suitable option is not option 1. It is option 2, which is hard. I know it's not fair, but what to do? That's life. So here also, I think you will not get this type of question, but if it is given by any chance, if it is given, do not use the nice value, I mean, round off value 340, because they have given the exact value 339.89. The other isotope given 342, the nice value, but within bracket it's given, then there is a printing mistake here. 42.0, but no, it should be 342.02. 3 missing. It's a printing mistake. Next isotope given 343. But the value should be 334.30. Percentage abundances next given like 32.94. This one 43.53. This one 23.53. Is that then 70? Yes, good. Then you ask to find out average atomic mass. The method is same, the chemistry part is same, but the difficulty is the simplification. I know that. Plus, this is 342.02 times 43.53 divided by 100. 334.30 23.53 divided by 100. You won't get this type of question in exam because exam question will test your chemistry knowledge, not the maths part or something. Here, I don't even simplify. Do you want me to simplify this? That's a problem. And give the final. 11th question. The diagram represent of the mass spectrometer of chlorine. I hope I explained that one somewhere in the class. I'm talking about 11th one. Mass spectrometer is given, intensity and everything, but here you see 20, 40, it's given masses 20, 40, that's the way we get it, and 60, 80, right? Then peaks are found, A peaks found somewhere here, it's given 30, 35, peak A. It's given 30, 37 and everything. Yes, it's given 35, the numbers given. Then B 37, this is B peak and it's 37. Next C, you get 70 somewhere here. C, you get 70, it's C. Thereafter D 72, D 72, and you get finally 74, E 74. Sorry. This is about chlorine sample. This is the mass spectrometer, the mass spectrum you obtain if you insert chlorine sample to the mass spectrometer and do the experiment. But the question is identify A, B, C, D, and E. Look at this one. Chlorine, I'm talking about chlorine. Chlorine has two isotopes. One isotope is 35 isotope. What's the next isotope? 37 isotope. Those are the two isotopes you can have. Then next thing I told you, once you introduce the vapor, the gaseous state of the sample, there is a beam of electron. As a result of this beam, positive ions are formed. Then this is actually 35 Cl plus. This is 37 Cl plus. Those positive ions are attracted, and then that undergoes then deflection under the magnetic field. If you remember, we discussed there. Yeah? So then 35 Cl plus is here. Very easy to understand. What is that? It's A. A is for that one because 35 directly given. Then 37 Cl plus, no need to mention plus. If you at least identify 35 Cl isotope, that's enough. A peak is for 35 chlorine. B peak is for 37 chlorine. That's okay. Anyone can understand. But what is C? It's 70. 70 means 35 plus 35. Then the thing is this. I told you it's a chlorine sample. In chlorine sample, how do we find chlorine? We find chlorine as a diatomic molecule. Diatomic molecule means two atoms combined, joined. That's how you find chlorine. Then look at this. If both chlorine atoms are from 35 isotope, even the overall charge of this plus, it's a molecule, yes, but once it is exposed to beam of electron, ionization can happen. Therefore, it's plus. Not necessary to put plus. At least you identify this like this. For C, it is okay. 35 chlorine combined to give a peak C. Thereafter, you can identify 72. What's 72? Then in this diatomic case, one can be 35, other can be 37. 35, 37, you see 72. That is for peak D. It exists as a molecule, not atom. Sometimes the bond is broken. This Cl-Cl bond is broken. Then you have individual atoms. In that case, 35 atoms, 37 atoms. But sometimes not all molecules then broken like this. Therefore, they exist as a molecule, diatomic molecule. 74, then E you can easily identify. It should be 37 Cl 37 Cl combined. That is where you have then E, peak E. Just giving these numbers in this manner for A, B, C, D, that's enough. No need to explain anything. They ask identify A, B, C, D. 341.81, the previous last one. Let's see. 300, yeah. We'll see that. Let's continue these things. I'll come back to 10th one later and then explain it. Nothing to explain. I mean, the simplification part is the thing. Got it? 11th one, the answers should be like this. Hurry. Let's continue with without wasting time. 12th question. It's quite uncommon question, but I hope you have given the answers correctly. Look at this. I mean, certain distance is given. What's that distance? It's 1.6 10 to the power of minus 3 meter. 1.6 10 to the power of minus 3 meter. That's the distance between this point and this point. But within that area, you have a part of wave A and part of wave B. Part of wave A. Like this, I mean, this way. This is wave A. It's a part of wave A. Starting from this point to this point, we get the part like this. There is a wave B also. Wave B like this. It can be drawn like this. These distances are identical. This is the part of wave B given. But same distance we consider from this point to this point, 1.6 10 to the power of minus 3. From this point to this point, 1.6 10 to the power of minus 3 meter. Correct? Now, which wave has the longer wavelength? For this, we have to go through the definition. You all remember the definition. What's the definition? Wavelength. It's the distance between two consecutive similar points. Maybe peaks. Peaks. Or crest. It's this one. This point and this point are similar. That's the wavelength for A wave. I take it like lambda A. This point, the distance point, this one. I mean, these two are the two similar consecutive points in wave B. The wavelength, I take it like lambda B. As you can see here very clearly in the diagram, lambda B less than lambda A. Which wave has the longer wavelength? Since lambda A greater, your answer should be wave A. Wave A is the answer for part A. Then calculate the wavelength. Next question is that. Calculate the wavelength. Yeah, good. Once you are asked to calculate the wavelength, you know how to do that one. Then how many lambda A's are there? This is also lambda A. This one also lambda A. This one also lambda A. How many lambda A's are there? 1, 2, 3, 4. Then someone can write it like 4 lambda A equals this total distance. Everyone can understand it. Anyone cannot understand, let me know. Within the diagram, this information given, the distance from this point to this point, 1.6, 10 to the power of minus 3. But wave A, if you consider wave A, according to definition, lambda is this length. But if you carefully look at the other wave, these also lambdas. But how many lambdas? From starting point to final, there are 4 lambdas. 4 lambda should be equal to this total distance, 1.6 10 to the power of minus 3. Then lambda A can be found. This divided by 4 means 0.4, 0.4 10 to the power of minus 3 meter. Or in other words, lambda A, 14 to the power of minus 4 meter. Do the same thing for the other. But is that 4 lambda B equals 1.6 10 to the power of minus 3 meter? No, that's wrong. It's not 4. Then how many here? Then look at this. All of these are lambda B's. Then from between starting point, final point, how many? 1, 2, 3, 4, 5, 6, 7, 8 lambda B's available. Then divide 1.6 by 8, you get 0.2 10 to the power of minus 3 meter. In other words, lambda BB will be 2 10 to the power of minus 4 meters. You asked to calculate them, and we calculated it. 0.4. Yes. Got it? Once I explain, sometime maybe you were stuck when you tried to do the question, but when I explain it, you will see that, oh my God, this is the way I should simplify. This is the way I should analyze. That's the experience you gain through this discussion. That's really important. You will understand the importance in future, not now. Hurry. Now I move to the other part. See, which wave has the higher frequency and larger photon energy? Calculate these values. Oh my God. Which wave has the larger photon energy and frequency and everything? Then it is clear. You know, then lambda A less than, sorry, lambda A greater than lambda B. Then what about the frequency A, frequency B? We know frequency is inversely proportional to wavelength. Inversely proportional to wavelength means greater should be smaller. What about energies? Energies are directly proportional to the frequency. Then smaller. Okay. Then higher photon energy found in wave B. Higher frequency found in wave B. But shorter wavelength is found in wave B. Those are the information, but they asked to calculate it. That's the question. But you know how to calculate, if you know the lambdas, you can find the wave. Well, how? Mu equals, C divided by lambda A. C equals mu lambda. C 3 10 to the power of 8 meter per second. What about the lambda A we calculate? It's 4 10 to the power of minus 4 meter. The meter cancel. I asked you to simplify first unit, then per second we remain. 10 to the power of minus 4 up plus 4. Plus 4 plus 8 plus 12. 10 to the power of plus 12. But 3 divided by 4. 3 divided by 4, it's 0.75. Quickly we can find it out. Easy. This becomes 7.5 10 to the power of 11 per second or hertz. That's mu A. Got it? Let's calculate then mu B. Mu B means frequency of B. That will be C over lambda B. C will be constant. We know the value. And what's lambda B? Lambda B. This one. 2 10 to the power of minus 4. These are not difficult. Very difficult simplification. Very easy. Therefore, never use calculator for these things. So minus 4, it's again 12. But 3 divided by 2, it's 1.5. It is per second. Just 1.5, 10 to the power of 12 per second. But they ask about something about the photon energy also. Wave B, yes. Wave B, yeah, correct. They ask about photon energy. Photon energy can be calculated now. There are two equations. If you use lambda to calculate it, it's hc divided by lambda. If you use frequencies to calculate energy, then E equals h mu. Let's use that one. EA equals h mu A. H constant 6.63, 10 to the power of minus 34 joule second, mu A. Where is it? Mu A, this one. 0.7 power 7.5, 10 to the power of 11 per second. You know, per second cancel, you get joule. I'm doing this quite fast because within the class, I'll explain how to do the simplification step by step very slowly. You understood it? There are 10 to the power of plus 11 minus 34. What's that? Minus 23. Plus 11, 34, 23. 10 to the power of minus 23. Next thing, 6.63, 7.5. 6.63, 7.5. We get 49.725. 49.725. In other words, scientific form 4.9725, 10 to the power of minus, here, one decimal place. Left hand side means it should be minus 22 joule. It's the energy of the wave A. Photon energy of wave A. It's a quarter. We go to the photon energy of wave B. We can use the same equation. What's that? For B, we can take EB equals H mu B. H again constant 6.63, 10 to the power of minus 34 joule second. But what about mu B? Mu B we calculate. Where is it now? It's 1.5. 1.5, 10 to the power of, if I write it, can you see it? Yes. 10 to the power of 12 per second. Then per second cancel, we end up with joule. Minus 34 plus 12, it's minus 22. Then 6.63 into 1.5, 9.945. Good. 9.945 I used it. $9.945. Which wave has the faster velocity? What type of electromagnetic radiation is illustrated? They ask which wave has faster. Yes. Which wave has faster velocity? That's a tricky question. How do we compare the speed of two electromagnetic waves? Nothing to compare. If it is electromagnetic radiation, all the electromagnetic radiation travel with speed of light in vacuum. Maybe ultraviolet, speed is 310 to the power of 8. Maybe infrared, the speed is 310 to the power of 8. Maybe visible, the speed is 310 to the power of. So even the calculations you see, I use the same Z anyway. See this one for wave A. Where is it? See this one for wave B. I use same value. Therefore, which one is faster, which one is slower? No, both have the same speed, and that's equal to speed of light. Both waves travel at the same speed, and that's equal to speed of light. What type of electromagnetic radiation illustrated? Then can we find it from wavelength or something? Wavelength, 410 to the power of minus 4. Using that, it's quite difficult, but actually, 410 to the power of minus 4 mean it's like 4 into nanometers, because in the diagram I gave nanometer or something. I gave you some kind of diagram or something. 410 to the power of then minus 5 plus 5, then 10 to the power of plus 5 nanometer. This can be like 2, again 5, 10 to the power of plus 5 nanometer. How to convert meter to nanometer, everything will be discussed under unit 3. It's a chemical calculation part, converting one unit to the other. Chemical calculation. Here I directly did that one, but spectrum colored. Did I give the values also? Yes. It's given in meters. Let's see whether we can use it. Under the colored pictures, figures, I share this one. What's this in meters? 10 to the power of minus 4 meter. 10 to the power of minus 4. Where do you find it? It's here. Eh? This is 10 to the power of minus 3. This is 10 to the power of minus 6. Then minus 4 will be here. Minus 3, minus 4, minus 5. This is minus 4. Using the diagram, we find it like microwave. Eh? Can you see that one? This area. This is 10 to the power of minus 4. Only the power. Then it should be what? Microwave. Microwave. This area you can see it. Next one, again 10 to the power of minus 4. Again, we find that one in the same place. Here. Means both of these two microwave. Both of these two microwaves. But the thing is, this one, you don't have to memorize the regions and everything. But, you know, then this was given in the books, the resource book also. Therefore, better you have some idea. But there is a very, very clear margin for visible. It's 700 and 400 nanometers. Definitely, you should remember that one. But other than that, better you have some idea about the other regions also, roughly. Because we are looking for not just S pass, I told you, not just C pass, not just B pass, or not even just A pass. I asked you to target 99A. It's possible. You have 2.5 years. You have 2.5 years. Therefore, it's really possible. You have enough time. If you have a target or burning desire to get 99A, you can do it. In that case, then we should be ready for any type of question within the syllabus. Right? So therefore, that's why I say it is safe. You have some idea about the wavelength ranges, yes. So that's the way we answer the question number 12. So what about this program? It's a good thing or bad thing? I mean, discussing questions in homework sheets as an online class. Because most of you are physically attending students to the classes. Sometimes you're not good in online part. You sometimes hate online. But I think if I take this time in the class, that will reduce the time available to cover the syllabus. So my target is to cover the syllabus quite earlier and give you, make you free in the last at least 2-3 months. Once you are free of theory in the last 2-3 months, then you will get, you will understand how important that is. Not now. Now you don't see any importance of covering the syllabus early or anything. But you can ask that one from 2025 student now, because they are going to have the exam this November. But most of them struggling to cover the syllabus. In that case, they are under stress. That's not good in the last minute. So if you have covered it quite early and then you are free of theory, that makes your confidence quite high. For your batch, then I'm planning that one. So, this one, I didn't do this one for the other batches, like 2026 batches. No, I didn't do it. 2025 batches. No, I didn't do it. I discussed those things within the class. I'm doing that one now in this manner for your batch means, my target. Only 34 minutes available. So it's very clear then we will not be able to finish this within this class. So we need one more class to finish it. Therefore, better you make that Friday evening free. I don't then put the classes for the other dates. Then I keep this one for your homework sheet. Right? So make that Friday evening free. Most probably I will put then homework discussion, online sessions, Friday evening. Right? I don't take like 3 hours. Normally, if it is permanent online class, I keep online classes 3 hours. But I don't put a 3 hours class because you are not online people in it. That's why I keep it like 4 hours, 2 hours. Then 2 into 2, 4 hours will be enough for this. So when are you doing physically? Yes, physically I'm doing Sunday 8 to 12 Farade Kandy. Farade Kandy. Tuesday 6 to 9, but I plan to increase the time, you know that one, maybe 9:30 somewhere. After about 1 more month, I will increase it anyhow. It's a kind of night class, evening, 6 p.m. to 9 p.m. 6 p.m., 9 p.m. Oh, most probably it's 9:30. That is Farade Vattala. These are the places you have. Where are you from, Ali? Kandy, ne? Yeah. Then Sunday 8 to 12, suitable, ne? Hari, let's move to 13th one and try to complete at least the questions up to 20. The past paper questions will be discussed the next day. That's the most important part. All of you should participate. I know, you know, today most of them absent. Maybe they are asking for recording. But recording is not available. Sometime after about 1 week or 2 weeks, I will upload this one to the YouTube channel. That is where you can watch it. But they have to wait for 1 week or 2 weeks. So that's the case. I always then advise you to participate, attend each and every class. That's really, really important. Don't miss any classes. At least for online live classes. Don't keep the recordings and everything. It's not successful. Microwave radiation has a wavelength and order of 1 centimeter. Lambda microwave 1 centimeter. Centi means, you all know what is centi. Centi means 10 to the power of minus 2 meter. Calculate the frequency and the energy of a single photon. Then for single photon, frequency can be C over lambda. C means the constant 10 to the power of 8 meter per second, lambda 110 to the power of minus 2 meter, meter cancel, minus 2 comes up, 10 to the power of 10, and 3. It's per second. Yes, good. This should be the frequency, but they ask photon energy, single photon energy. You know that single photon energy is this one, H means. This E refers one photon, I told you. Photon is the particle of light, I told you. Photon word given by Albert Einstein, I told you. Planck gave another term for this one. What's that? It's quantum, right? Yes, then since you have the frequency, you can simply multiply the Planck constant by the frequency you calculate. Okay, joule second, it's 310 to the power of 10 per second. Per second, second cancel, you get this 10 to the power of 10 minus 24. Good. And you end up with joule, not kilojoule. And 3 into this, 339, 18.1, 18.1, 19, 19.89, 10 to the power of minus 24. Or 1.9, 10 to the power of minus 23. 1.9, 10 to the power of minus 23. Calculate the energy of an Avogadro's number of photon of this. What is that? Energy of Avogadro's number of proton mean it's about 1 mole of photon. You know Avogadro's number, this name. Then whatever you consider this number of units. If it is electromagnetic waves, if you consider this number of electromagnetic waves, that refers 1 mole. Therefore, energy of 1 mole, I have given the equation h mu times L. Energy of 1 photon equals h mu. Energy of 1 mole of photon, h mu L. L is the Avogadro's constant. Then we already got this value. H mu value we calculated. It is 1.989 scientific form, or 19.89. You can keep it. 10 to the power of minus 24 joule. Sorry, minus 23. If I take it like 1.9, that should be multiplied by the Avogadro's number. Actually, Avogadro's number has a unit. That will be discussed again under calculation. Avogadro's number will be there. There is a unit actually, it's per mole. But here, I don't check that one because you don't know that. Actually, here the unit should be joules per mole. That's correct. We are talking about 1 mole of photon. The answer should be joules per mole. Minus 23 plus 23 cancelled out. Good. Then 1.98910 into 6.022. That's the simplification. 1.989. 989 6.022 11.9777 11.977. I take it like 98. Yeah, just 11.98 joules per mole. 10 to the power is cancelled. Yes, cancel. That's the energy of 1 mole of photons. So 5-minute breaks. 5-minute break. So for 13th A part, this to the power 26 kilojoules, right? 13th A. 13th A, calculate the frequency and the energy of a single photon, 1 centimeter. Frequency. This is okay. Energy, h mu, 6.63, 10 to the power of minus 34. 3 10 to the power of 10. Frequency, plus 10, minus 10, minus 24. 3, this is, okay, 19, 10 to the power of minus 24. 1.9, if I keep 1.9 minus 23, that's correct, ne? 1.9, 10 to the power of minus, kilojoule, yeah, right, kilojoule. Yes. I mean, kilo mean, then we divide that by 1000. If you want to convert joule to kilojoule, you divide that by 1000. Or multiplied by 10 to the power of minus 3. If you multiply this one by 10 to the power of minus 3, this will be 19.89 10 to the power of minus 27 kilojoule. But if you keep 1.9, yes, it's minus 26. Yes, correct. But I see you answer, your name like Zoom user. Then Mr. Zoom user, yes, it's correct. Aren't we allowed to take this one? Can I keep the frequency as 30? Frequency as 30. Oh, frequency as 30. Yes. No, 30? No. 3 into 10 to the power of 10. It's 3 into 10 to the power of 10. Not 30. 30 means 10 to the power of 1. All right. We know, right. Got it. All right. Then just 25 minutes. Do you need 5 minutes? Then I will keep it like 10 like that. Is it okay? No need. You took it yourself, right? Good. I went to drink water. Yeah, in online, you have that facility, ne? You can take about 1 minute, 2 minute break. But better you keep everything around you when you start online. There is online class mean there is a certain procedure you continue with. Self-discipline and everything there. But since you are a physical student, I don't have to explain that one, how to get the maximum benefit out of online class. It's something you need to study. But it's not important for uni. Yes, we'll finish questions. 14th one type of electromagnetic radiation has frequency. This another type. Okay, there are 3 type of electromagnetic radiations given. They are asking something. I'm going to erase this because I need more space for the next question. Question number 14. One type of electromagnetic radiation, let's say it's A or something. Frequency given, mu given, it's 107.1 megahertz. Mega. We discussed that one in class. You remember that? I take the type B. Wavelength given, not frequency, it's given wavelength 2.12 into 10 to the power of minus 10 meter. And another type, let's say C has photon energy. It's given photon energy, E given 3.97 10 to the power of minus 9. 3.97, yes, 97 into 10 to the power of minus 19 joule. That's what you are given. Yes. Identify each type of electromagnetic radiation and place them in order of increasing photon energy and increasing frequency. They asked to identify it, ne? Which one is good? I mean, I think lambda will be good to identify it because in that diagram I showed in electromagnetic spectrum, I have given the lambda values given nice and it's, easy to compare. Let's keep it in meter and let's calculate lambdas. What about lambda? Lambda is C over mu. C 310 to the power of 8 meter per second. And what about mu? Mu is 107.1 mega. Mega. Wherever you see mega, you can replace that with 10 to the power of plus 6. We discussed that in theory. Mega 10 to the power of plus 6. Hertz can be replaced with always per second. Per second, cancel. Then we can have the wavelength in meter. It's 10 to the power of 6 cancel with this 300 divided by this. 300 divided by this, is that what we get? 3 10 to the power of 8 meter per second. Okay, this is 107 10 to the power of 6. Yes, ne? This cancel. It's 300 divided by 107. 107.1. So what do we get? 2.80 meter. Oh my, there's a huge difference. Why? Okay, it's okay. According to the values given, this is the way we end up with. Did I write the equation correct? C equals mu lambda, then lambda C over mu. Yeah, everything correct. This is okay, yeah. Okay, we got lambda A, we got lambda B, then we are going to have lambda C. But you know, equation E equals HC over lambda. Lambda equals HC over E. HC over E. That's the equation. 6.63, 10 to the power of minus 34, 3 10 to the power of 8, meter per second. Energy given 3.97, 10 to the power of minus 19 joule. So joule cancel, second per second cancel. We end up with meter. Yes, that's what we want, meter. Then only we can compare it easily. 10 to the power of minus 19, this is 15. Yeah. 34 minus 19, it's 15. Yeah. Minus 15. But 10 to the power of plus 8 minus 15, it's minus 7. So we get minus 7. 10 to the power of minus 7. But 6.63 into 3. 6.63 into 3 divided by 3.97, 5.01. 5.01 10 to the power of minus 7 meter, or minus 7 minus 10. This is just 10 to the power of plus 1. They asked what type of electromagnetic radiation given here. Identify each type of electromagnetic radiation. If we refer the spectrum again, I need the meters. Let's start with this. This is 10 to the power of, you can write it like this, 2.80 into 10 to the power of 0 meter. 10 to the power of 0 meter mean 1. 10 to the power of 0, yes, radio waves, good, they found the position. We are happy about that, you see. This is where you find wave A, it's radio wave. Wave A can be radio wave. B, 10 to the power of minus 10 should be found. Where is it? Minus 10. It is here. This is where we find minus 10. What's that? Gamma. B is gamma. C minus 7. C minus 7. Where is it? Then this is where we find C. It's most probably ultraviolet. C ultraviolet. But okay, then we identified the type of electromagnetic radiations. Now you need to get the photon energy. Okay. Then they asked to arrange them according to increase in order of photon energy. Question is identify each type, place them in order of increase in photon energy or increase in frequencies. Yeah, then what about that? Let's take lambdas. According to lambda, because we have the values. Which one is the shortest one? Minus 10, minus 7, 0. Then minus 10 means B. Thereafter C, the largest one, this one, it's A. Lambda. Then frequency, other way around. Inversely proportional. A, C, B. Photon energy, same as me. A, C, B. This is the order when you place them. What is cosmic rays? What is the use? There is no use. Cosmic rays mean fast moving small particles. Fast moving small particles. If these small particles are subatomic particles, then you know nuclear, those are the uses. It's the 14th one. 15th one, my target is to finish at least the 20. Then next day we can finish past paper 20 and story finished. Okay, let's move to question number 15 quickly and discuss it. 15th question, carbon oxygen double bond in a certain organic molecule absorb radiation that has a frequency this. Carbon oxygen double bond in organic compound. Aldehyde has this, carboxylic acid has this, but don't worry, we will come to that under organic chemistry. What is the wavelength of this radiation? That's the question. But you know what is given here? Frequency. Simply you substitute 310 to the power of 8. Frequency given 610 to the power of 30. 13 per second. So per second cancel. 8 and 13 cancel. It's 5 here. 10 to the power of plus 5 comes up minus 5 meter. 3, 6 mean half. Half mean 0.5. Or in other words, 510 to the power of minus 6 meter. B, to what region the spectrum does this radiation belong to? Again, you can find it like, 5,000 nanometer. It's not good, not visible though anywhere. Then you have to go to that spectrum. 5 10 to the power of minus 6. 5 10 to the power of minus 6 is infrared, IR. You can go through that diagram and find it. It's infrared. See, what is the energy of this radiation per photon per mole? If it is per photon, it's Hc over lambda, but frequency it's directly given. Therefore, better you use h mu. 6.63 10 to the power of minus 34 joules second. You know, once we practice this question, that's enough. I mean, just 20 questions enough to have very good confidence here. Frequency 6 10 to the power of 13 per second cancel. Joule 13 minus 34 minus 21 6 3 18 1 6 6 31 37 3 6 6 3 39 39.78 10 to the power of minus 21 or 3.978 10 to the power of minus 20 joule. Kilojoule minus 23. That's for per photon. They ask per mole of photon also. So if it is mole of photon, only thing you need to do, this is 1 photon energy per mole. What should I do? Then we just, shall I write it here or somewhere? I write it here. Per mole, you multiply this value by the Avogadro's constant. 3.978 10 to the power of minus 20 multiplied by 6.022 10 to the power of 23. Minus 20 cancel with this plus 3. 10 to the power of plus 3, it's joule. Joules per mole actually, but you don't have to worry about per mole part. 3.978. 6.022. 23,955 like that. 23,955 mean 96. Or 2.396 10 to the power of 4. Got it? 15th. There is another part. A carbon oxygen bond in a different molecule absorbs radiation with frequency equal to this. There is another carbon oxygen bond. It's a double bond or maybe single bond. It's not mentioned. Carbon oxygen just bond. That absorb frequency like 5.4 10 to the power of 5.4 10 to the power of 13 per second. Let's say mu B. What is mu A? 6 10 to the power of 13. This is 5.4 10 to the power of 13. Then when you compare mu A, mu B, mu A greater, what do they ask? Is this radiation more or less energetic? This radiation is less energetic. Why? Energy varies like this. Got it? I compare mu A 6 10 to the power of 13 with mu B 5.4 10 to the power of 13. So 10 to the power of 13 common. And then I compare this value 6 and 5.4. So 5.4 lower, less than. Then frequency less mean energy less. It says more or less, it should be less. Question number 16. What is the wavelength of an electron moving with the speed of, this is about then electron is a particle and it moves with this speed, then they ask wavelength, that is where it behaves as a wave. This is about de Broglie wavelength. This is a direct application of the equation given. Then everyone can answer it. If you remember the equation, we can answer it. Out of ink. Okay. I'm talking about 16th one. What's that equation? Since it's lambda and h, mass given, speed given. Therefore, I use that equation. Lambda equals h over p, lambda equals h over mv. Since mass and everything given, this is the one we use. Then let's substitute the values. H given 6.63 10 to the power of minus 34 joule second. Mass of electron also given 9.1 10 to the power of minus 28 gram. And this one is given like speed 610 to the power of 6 meter per second. But we have to be careful here in the case of units. I think I mentioned that one even within the class. H is in joules second. Mass, if I keep gram, V ms minus 1. Can we have lambda finally meter? That's the question. But I think no. Because joules can be replaced with Newton meter. This is grams ms minus 1. You know the simplification of units. I think I did this one. Then what about the Newton? Newton is kg ms minus 2. You know, Newton is kg ms. Kg means kilogram. Then you can't substitute this in gram. That's the problem. That's the important thing when you apply this equation. Should be converted to kilogram. To convert that into kilogram, you can multiply that by 10 to the power of plus 3 or divide that by 10 to the power of minus 3. Then it is kilogram. This must be in kilogram. Everything cancel. You can easily get the unit for lambda like meter, SI value. Okay. Right. Then 10 to the power of minus 28 minus 3, it's minus 31. Minus 31 cancel with this minus, then 3 remains. Plus 6 comes up, minus 6. Minus 6 minus 3, it's minus 9. This way is easy. Thereafter, we get this simplification, the numbers. What are the numbers? 6.63 multiplied by, no, divide by 9.1, and that's divided by 6. 0.1214. 0.1214. In other words, 1.214 10 to the power of minus 10 meter. Angstrom. Minus 10 mean angstrom. Mass of an electron. Okay, then they ask wavelength. Hurry. 17, calculate the velocity of neutron whose de Broglie wavelength is picometer. Mass of neutron is given. Then again, direct substitution. I'm talking about 17. They ask the velocity. Velocity. Then take velocity to this side. Then what's the velocity equals h divided by m lambda. H is always constant. That value is 6.63. We use it minus 34 joule second divided by m. Mass of neutron 1.67 minus 4. 1.67 10 to the power of minus 24 gram. Again, gram is not good. Not correct. Therefore, should be converted to kilogram. And then lambda also given 500 picometer. What about pico? Pico, you know, deci minus 1, centi minus 2, milli minus 3, micro minus 6, nano minus 9, angstrom minus 10, pico minus 12. Pico minus 12 meter. Then you can find mu in SI unit, meter per second. Simplify it. I mean, minus 24, minus 3, minus 27, minus 20, minus 7. It is minus 7. The minus 7 cancel with this minus 12 means minus 5. Minus 5 comes up, it becomes plus 5. Even 2 zeros cancel, but use that one as 500 in simplification. 6.63 divided by 1.67. That's divided by 500. What do we get? 0.00794. 0.00794. 0. Then it's like 7.94 10 to the power of minus. No, 5 times. 1, 2, 3, 4, 5. Just 794. 794 meter per second. 10 to the power of 5 mean 5. Yes, 794. That's the answer for the 17th question. 10 to the power of convert in gram to kilogram, you divide 10 by 1000 or multiply -3. Then somewhere, did I do any mistake? No, I think. Correct. That's about 17. Let's move to 18th. And our target is to finish 20 anyhow. But 1 minute remaining. A proton and electron have same kinetic energy. Which one has a smaller de Broglie wavelength and why? This is about de Broglie wavelength and kinetic energy. Then you have to use the third equation. If you compare de Broglie wavelength and kinetic energy, you need to use the third equation. What's the third equation? I'm talking about 18th one. It's about this lambda h square root 2me. That's the third equation. I explained how to derive this one within the theory class. Right. What's the thing? Proton, electron have the same kinetic energy. Which one has smaller de Broglie? But same kinetic energy is there. Proton, electron. Look at this one. All right. Now, H2E constant. H constant, E constant, 2 constant. If these constant, I can say lambda inversely proportional to square root of mass. Is that clear? If H2E constant, lambda is inversely proportional to the square root of mass. Now you know when mass increases, lambda de Broglie wavelength should decrease. Because kinetic energy is same. Now it's very clear. Mass increases, lambda decreases. Then out of proton, electron, which one is then having higher mass? Mass of proton, mass of electron. Which one is larger? Definitely proton. Proton is heavier. If the proton mass greater, then wavelength of proton should be smaller. De Broglie wavelength of proton should be smaller than the de Broglie wavelength of electron because proton is heavier than electron. If you have written these things, that's enough. 18. 19. Find the ratio of de Broglie wavelength associated with 2 electron having kinetic energies 25, 36. 19 again kinetic energy. This equation applied. 2 electron. That's the important thing. 2 electron. 2 electron means same. Mass is same. H same, 2 same, and then these are cancelled. Okay. To first electron, I apply this. Let's say to first electron, I apply this wavelength lambda 1. H divided by root 2m kinetic energy is given 25 joule. 25 joule. This is first equation. They ask the ratio. I'm going to get the ratio. Lambda 2, this is to second electron. To second electron, we apply the equation lambda 2 h root 2m. M same, mass same, electron. But kinetic energy is different. It's given 36 joule. This is second equation. 36 joule. Good. To get the ratio, what I need to do here, divide it. Divide the first one by second one. So you get the ratio lambda 1, lambda 2. But these things not comfortable, but division can be written as a multiplication, then upside down. That's what happened. Then here h, here root 2m, 36 joule. 36 joule. HH cancelled out. So lambda 1 over lambda 2 can be root 2m 36 joule divided by 2m 25 joule. Let's go to 2m also cancel, joule cancel. What is this? 36 over, actually root 36 is what? 6. Root 25 is what? 5. We can simplify it like that. Root 36 easy. 6 into 6, 36. 25, 5 into 5. Then 6 over 5. 6 over 5 means 0, not 0, 1. But they ask ratio. Ne? What do they ask? Find the ratio. Then we just leave it like this. Ratio. What's the ratio? 6 is to 5. lambda 1 is to lambda 2, ratio should be 6 is to 5. 19, 12. Right. The thing is, today I'm recording not to the cloud. Proton has a smaller wavelength compared to electron when both have same energy. Yeah, that's what we discussed. Ne? Proton has a smaller. Yes. You are giving that answers. Ne? You have sent me the answers for the one. Better you send me WhatsApp message. I'll check it. Because we are in the last minute. No, we pass 10. I want to finish 20th one also. Then any doubt regarding this now in the last sleeve? Send me the answers through the WhatsApp. Then I will check it and let you know. Let's go to 20th one because, then I see some of you are having problem sleep. Maybe this is your sleeping time. Ne? A proton and alpha particle. I'm talking about last one, 20th one. Alpha particle have the same de Broglie wavelength. By assuming the mass of a proton and neutron are same, determine the ratio of their kinetic energies. Okay, same story, same equation we use. I think. I need more space, therefore I erase it. In that case, I share the screenshot so you can download it. Remember, I want you to write the reviews in your word for all these 20 questions. Maybe already you wrote it, but if you have missed it, I want you to write it. Proton and alpha particle have the same de Broglie wavelength. By assuming the mass of proton neutrons are same, determine the ratio. Hari, proton, neutron. Lambdas are equal, masses are also equal. We need to identify the ratio of Hari. Let's say kinetic energy here EP, kinetic energy here En. How to do that? To proton, we can apply this lambda equal H divided by 2 again M, just M equal EP. This is first. Then to neutron lambda because it's equal. H constant anyway, mass is just M because that's again equal. Then the energy of neutron, kinetic energy 2. You need to find out the kinetic energy ratio. Ratio of this. You divide first one by second. So simply they are equal anyway. This side lambda cancel 1, 1. This side it's H over root 2m EP upside down root 2m En. That's what we have. Therefore, HH also cancel. When you do cross multiplication, no need to, then it's root 2m EP equals root 2m En. Actually, kinetic energy 1 is to 1. You can remove square root by taking the square of both sides. It's 2m EP equals 2m En. Shall I write it here? I don't know whether you can see it. I write it here. 2m EP equals 2m En. Then 2m, 2m cancel. We take En to this side. So it's then 1 is to 1. So kinetic energy ratio is also, equal. Means 1 is to 1. Simply we can take it if lambda equal, if m equals h and 2 anyway constant, then definitely kinetic energy should be equal 1 is to 1. And they asked to get it their speed also. This is first part. Second part is speed. If you are talking about speed, then we need the second equation mv. But here also, to apply this one to proton, it's lambda p. It's just lambda because equal. H divided by m, just m because equal, then mu p. It's again same way, 1 is to 1. To neutron, lambda h over m vp vn. Then these two equal, then but divide the first one by second, you get 1 is to 1. H m vp times m vn divided by h, or h cancel, mm cancel. What do we get? Vn over Vp equals 1 divided by 1. Means 1:1. So here also, Vp Vn is 1:1. Here I prove it by doing calculation, but using the equation also we can prove it. If lambda hm constant, V also constant. Then I discuss all the 20 questions given to do they talk about alpha particle? My God. It's given a proton and alpha particle have the same de Broglie wavelength by assuming the mass of proton and neutron. My God. It's not neutron, eh? My God. Alpha particle. Good, you notice it because I completely miss it. Alpha particle means actually 2 protons and 2 neutrons. Lambdas okay, but masses. If mass of proton m, actually, what is this? 4m. Ne? I compare proton and neutron. That's the case. Question is about alpha. Sorry. This is m 2m, but this is 4 mean 8m. I just write it 2 into 4, 8m. 1 over 2, 1, 1, h over 2m EP. This is 8m en. So the 2m EP, this is 8m en. Remove that one. So this is 8m. MM cancel 2 and 8, it's 4. EP over En is 4:1. My God. That should be 4:1. I mean, the kinetic energy ratio 4:1. Because the question is about proton and alpha particle. Mass of proton and neutrons are equal, not alpha. Alpha particle mean 2 proton, 2 neutron. Helium nucleus. Atomic number 2, mass number 4. 4 particles total. If mass m, this is 4m because mass of proton, 1 proton equal. Even mass of proton neutrons are approximately equal. Yes, it's given anyway. This is the case. Then if I go to this one again, for proton, this is okay. This is not neutron. This is alpha particle. If this is m, this must be 4m. Alpha particle 4m. So when I do it 1, 1, h over mp, this is 4m. mm cancel. So what do we get? It's then 4 times Vn over Vp. So if I take Vp over Vp is to Vn. So Vp is to Vn. If I subject it, 4 comes here, 4:1. Wait a minute. Yes. 4. I take equal. Vp is to Vn should be 4:1. Speed of proton should be greater than speed of neutron, alpha particle, not neutron now. Here, instead of N symbol, it should be alpha symbol. This is not neutron, it should be alpha symbol. This is alpha. N should be replaced with alpha. Earlier, I calculated for neutron and proton, but actually it is alpha. In each and every answer, N should be replaced. Hurry, now it's correct. Kumar, then yeah. So yeah, it should be alpha. I didn't read the question properly. Hari, I think you understood these 20 questions. Most of one already left it. Maybe their sleeping time is 10. They can't pass it because maybe they have classes next tomorrow morning. And they have to wake up, right? It's good, but you need to cover this one. And that's what I told you. I download this. I mean, I record this one in my computer hardware. I didn't record this one in the cloud. So then I cannot share that one within tomorrow, day after tomorrow somewhere, because first I need to upload this to YouTube channel. Then only I share it. It takes some days. So it's okay. You send me WhatsApp message asking for the recording, but then I will give you the link for the video. I try to upload that tomorrow, and at least tomorrow evening I can give it. I'll try it. Not sure, because tomorrow I'm having classes also. Hari, then this way we will continue another online session next week, Friday. That is to cover the past paper questions given. Okay, right. I think that's enough for the day. Yes. I enjoyed the class. I hope you all enjoyed it. It's sleepy, but you enjoyed. Right. Okay. Then good night. See you next week class. Bye bye. Okay, we'll come. Good night.